In this video, we're going to look at how we can analyze the frequency content of a microphone input signal in the engine, and how we can effectively mute the microphone input and use it to trigger audio and other events. In the first cave of the demonstration level, that's bookmark key 6, there are a number of burning torches lighting up this sacred place. Unfortunately, one of these torches has gone out, and this is likely to mildly irritate the ancient gods of this world. However, all is not lost, since the player carries some flint with which to relight the fire. You just need to put your lips together and blow. So this is the blueprint that controls that system, BP DC fire starter. When entering or spawning into the collision box, we have the usual check that it is the player character overlapping, and the input key E starts the system. Firstly, this creates a visual widget in the viewport to display a level meter. You can alter the threshold of this meter by using this public variable here, and the position of this will then be represented on the meter itself. So if I press E, I get that widget displayed, and you can see the visual graph on the left hand side. Now I'm just going to blow into the microphone in order to light the fire. You might have noticed that you don't actually hear the sound of me blowing into my microphone. Since this is a pretty unpleasant sound, we've effectively muted it. As we've seen before, we're using an audio capture component to capture the audio input, and this time we're sending the entire signal to a submix cave fire. If we open that submix, we can see that its output volume is set to 0. So although we can analyze the signal, we won't actually hear the microphone input. Once a sound has been sent to a submix, we can then analyze it. So here we've got a variable that references that submix cave fire. We do this simply by executing this node, the start analyzing output. This has various options for how the frequency analysis is to be carried out. They're all based on an FFT or fast Fourier transform approach, which we've discussed previously in the non-real-time analysis video. For our current purposes, we've just left these at the default values, which are a good starting point for most sources. You need to define what frequencies you want to analyze, and then later we're going to get the magnitude of those frequencies and add them to this array, current magnitudes. This setup section here just sets the size of the current magnitudes array to match however many frequencies we've defined in the frequencies to analyze array, using the size to fit option. And it sets these initial values to 0. Then the widget is set up using these threshold settings, and finally tick is enabled for the actor, and given that we're driving our analysis systems from an event tick, this effectively turns on the analysis system. Once the start analyzing output event has been executed, you can use the get magnitude for frequencies to get the current magnitude of whatever frequencies you defined in the array. In our case, we're just looking for a very low frequency that's generated when blowing into a microphone. So we've just defined one frequency to analyze at 100 Hz. So we get that array of magnitudes. In our case, there's only one element in that array. And then for each of these, we read through the current magnitudes and we set that to the current value variable. We set up a little debug system here. Again, that's on a public variable. So with that selected, we'll check that and we'll see the kind of values we're getting out. So I'm going to press E again, and I'm going to blow into the microphone again. You can see there I'm able to get values up to around 70 by blowing into the microphone, but they're pretty extreme. So we're just going to look for values between 0 and 60, and we'll set our threshold to 15. The threshold is going to be the value at which we're blowing enough to help light that fire. Given that we don't have attack and decay options on the frequency analysis, we've added a system to smooth out these values a bit. We take the current value as our target, and we use the interp speed to move towards this value from the previous value, which we've stored in the variable last value. If we set an interp speed of 50, you can see that the response is quite jittery. Whereas if we set a low value, like 1 or 2, the resulting audio analysis value is much smoother. Given that we've decided to use the range 0 to 60 for our meter, we divide the interpolated magnitude value by 60 and use this to set the meter's percent setting, which controls the progress bar. So looking in our meter widget, you can see that this is our level meter, and what we're doing is controlling the percent value here. The next thing you can do is to use the magnitude values of the specific frequency in your real-time audio input to control visual effects in the game. Here, the fire particle system component, PFX Fire Torch, has a parameter called spawn rate, which unsurprisingly controls the rate at which the fire particles are spawned. We take the interpolated magnitude of that 100 Hz frequency and we map it between the threshold level and the maximum level to the values between 0 and 1. I'm going to use this 0 and 1 for a few things, so we've assigned it to a specific variable called controller value. And the first thing we use it for is to set this spawn rate. And the second thing is to remap it to a different range between 0 and 2000 to control the intensity of a light component. Creating this system allows us to control the fire particle system and its perceived brightness by blowing into the microphone. I'm now going to just connect this up to our audio systems. Although we don't want to listen to the horrible sound of someone blowing into a microphone, we do want the audio in the game to respond to what's happening. So going back to our interpolated analysis value, when this passes the threshold, it will play the fire starter component and start a timer. The timer is not connected up for the moment so that we can focus on the first part of the system. We'll be coming back to this in a minute. The fire starter component is the sound that we want to hear when we're blowing and trying to start that fire. If the frequency magnitude falls below that threshold, in other words, if the player stops blowing, then the sound is faded out and the timer is cleared. And while we're blowing, that control value again between 0 and 1 is actually controlling the volume of that fire starter sound. So far so cool. However, if the player keeps blowing for more than 3.5 seconds, then the timer with function named start looping will trigger its corresponding custom event and will properly light the torch, playing a new fire looping sound and setting a constant spawn rate and bringing up the light intensity of the fire. Once this torch is lit, the visual widget is removed and the tick disabled for the actor, since we don't need it to be actively doing anything anymore. So effectively, if the player has the lung capacity to keep blowing on that fire for more than 3.5 seconds, then the fire will be permanently lit. So I'll just connect up that timer to complete the system. In the magical forest, the area surrounding this central clearing here has another blueprint called BPDC audio input butterflies. This works in exactly the same way. We've got audio capture, we're defining a set of frequencies to analyze, we're capturing those magnitudes. Then we're reading through them to see if they match certain thresholds. Now, unlike the fire starter when we're only looking at 100 Hz, we wanted to only trigger the magical effect, which is spawning butterflies, if the player is inputting very high frequencies, but not any low frequencies. In other words, if they're whispering or making a tss type sound. Like in the baby griffin example from a previous video, we've routed this audio capture to a source bus within the player character, so the sound appears to come from them. We've also sent some of the signal to a submix effect to give it a more magical feel. You can explore this a bit more in the demonstration project itself, but I'll just give a quick example. In this video, we've looked at how you can analyze the microphone input by looking at the magnitude of specific frequencies. You can use this to allow your player to interact with the game in new and innovative ways.